Circle C has this equation. Find the possible set of values of k. So I'm going to put it in x minus a squared form because it's the radius that's going to bring in conditions on k. It can't be negative, for example. It can't be 0. Right, so in our case, we're going to get, completing the square, x minus 3 squared. Then I need to minus 9 plus y plus 5 squared, please. Then I need to minus 25. And then plus k equals 0. So that means that x minus 3 squared plus y plus 5 squared is going to equal, that's minus 34, so it's going to be 34 minus k. And I just require 34 minus k to be greater than 0. Therefore, k must be less than 34. Then given that k is minus 46, so I'm just going to write out the equation, the non-completed square version, but with k is minus 46. We want to determine the coordinates of the 2 points on C where the gradient of the tangent is a half. I can draw my circle, and it's going to maybe be here and here, but I don't have much information on what's going on. I could obviously work out the center and the radius, but how do we then look for the gradient of the tangent? Well, it's actually going to be implicit differentiation. That's our dy by dx that we can then set equal to 0. Don't often get this in circle questions, but it's very much valid. So let's differentiate each term. We've got 2x plus 2y dy by dx. I'm using the chain rule here. Differentiate the outside, the y squared. That brings us 2y times by the derivative of the inside. That's the dy by dx. It's something you just sort of learn when you practiced it. Just basically differentiate it as normal and then times by dy by dx. Then minus 6 plus 10 dy by dx is going to equal 0. I'm going to rearrange this. So dy by dx times 2y plus 10 is going to equal 6 minus 2x. So this means that dy by dx is going to be 6 minus 2x over 2y plus 10. We can actually divide both through by 2 to give 3 minus x over y plus 5. Now this is equal to a half. So this gives me a relationship between x and y. It must be that 3 minus x is equal to a half, y plus 5. So y plus 5 is then going to equal 6 minus 2x, and y is going to equal, I'm going to write it as minus 2x plus 1. So that must be the case when dy by dx is equal to a half. So that is the condition at where it's the gradient's a half, and that will give me some points on the circle. But we also know that this equation here also gives me points on the circle, so I can solve them simultaneously. I'm going to sub in for y. It makes sense to do that one because there's no fractions then. So x squared plus, I'm going to write it as 1 minus 2x now, squared, minus 6x plus 10, 1 minus 2x, minus 46 equals 0. Expand this, I'm going to get 1 plus 4x squared minus 4x from that double bracket, then plus 10 minus 20x minus 46 equals 0. So 5x squared, and then I've got minus 30x, I think, minus 4x, minus 20x, minus 6x, and then I've got plus 11 and minus 46, that'll give me minus 35 equals 0. Divide through by 5. factorize this. Actually, it factorizes quite nicely. X minus 7, x plus 1, which means x is going to equal minus 1, or x is going to equal 7. And I can then put that back into the linear function. Okay, you could put that into the quadratic, but much easier to put it back into the y equals minus 2x plus 1. So when x is minus 1, I'm going to get 2 plus 1, I'm going to get 3. And then when x is 7, I'm going to get minus 14 plus 1, I'm going to get minus 13. And that's it. So our 2 points are going to be minus 1, 3, or 7 minus 13.